In this video, we're going to use, or rather, we're going to perform regression analysis using some of the available regression classifiers or algorithms. First, open the Explorer window, and then the next thing is to open load our dataset. In this case, we're going to be using the house dataset. So click open, and we can see we have 6 attributes and 14 instances. These are our 14 training examples, or sometimes we call them observations. And the name of our data set is called house. Again, you can visualize how the distribution of your columns or features are using the visualize all, or you can click here. And if you have a lot of data, you can actually increase this point and update that just to see how they are kind of correlated together. Okay, all these are just different features in Worker. All right, so the next thing looks like we don't have any missing data, so it's a good thing to just go scroll down and just each time looking at the name of the feature or the name of the attribute, percentage of missing, how many distinct, and numeric. Again, you can click on edit here just to look at how your data looks like in your house file, right? You can see this is the selling price. We have bathroom, it's one of the features, granite, bedrooms, lot size, house size. So the goal here is to try and predict the selling price given the house size, lot size, bedroom, number of bedrooms, right? You can see we have 6 bedrooms here. So in fact here, whether it has granite or not, bathroom or not, and whatnot. Okay, so click OK here. So click on classifier. Under the classifier tab, we can start with 0, right? This 0 is our benchmark, you know. So if our classifier performs worse than this, then it means our classifier algorithm is really bad for this type of data set. So with this, let's choose the test option, use training set, and click on start. You can see here correlation coefficient is actually 0. So it's actually, you know, no good as just doing some guess. In fact, it's so bad that it's actually 0. But let's go and choose some classifiers here. Let's start with functions. You can see all the other classifiers have been grayed out because they're used for classification. Worker just detects that actually this is a regression problem because our Y is continuous or numerical. So we start with the linear regression. Click on start. Again, we can see here our correlation coefficient is 9.372. So Worker doesn't give us the coefficient determination, which is the R squared. In fact, to calculate that, I'm just gonna plug here to calculate the, so we just square that. So when we square that to using the calculator here, we get our you know, our R squared. So our R squared here will be 87%. What that means is that, you know, that about 87.83% of the variance of housing prices in the data can be predicted by the model. So this is what this correlation coefficient is telling us. Then we have another important metric here called RMSE. What that means, this number, basically what it means, it just means that, you know, the RMSE here is $26,975. It just means that all the prediction for the testing set, the average difference for each prediction is this much, 26,975. Okay. So let's go and select other. So let's go ahead and select the simple linear regression. Click on start. Again, you can see here, it does slightly worse than this one. So again, let's choose the, so this is the support vector machine implementation for regression. So it's called MSO reg. And each of these, you can always click here to configure. By default, we're just taking the parameters at default. So fine tuning or these hyperparameters will just help to improve your performance. But for now, we're just selecting as it is. Click start. And you can see here, this does much better than the simple linear regression. Okay. So again, let's now go to lazy here. We can pick KNN. KNN is denoted as IBK. So select that. These are neighbors. You can see KNN1, right? We can change this number maybe to 3, for example. We've already looked at this in Python. And again, by default, it's just using the linear search. We'll leave this as it is. Click OK, then click on Start. You can see it doesn't do very well at 79. So if I just plug this one here, clearly here, this will be much lower. So if I just do the square root of 7978, I can see our variance is 63% of our data. Or variance is explained by our model. So that's not very good. Then let's go ahead and select one here called bagging. So this is an ensemble technique. If we configure here, you can see it's a kind of just uses trees actually. So here we can select maybe a random tree, for example, right? Again, it just tells us. So it's just an ensemble where the idea here is to use the wisdom of the crowd. You know, the crowd is better than one. So this is what ensemble it actually does, right? So click OK here. So we just select that just to fine tune a little bit. So click OK, click on Start. So this again goes up a little bit. Let's choose a little bit more here. So that's just from Meta. Again, let's go to so trees here. So another popular one, select here is random forest, right? So go ahead and click on that. You can see, oh, this one actually goes up. Actually, this is the best so far, 9.63, right? And if I plug it, this one here. So let me go and plug this one, 9.63, right? So actually here, this classifier explains, that means that 92.73% of the variance in our housing prices in the data can be predicted by this model. So that's good. Then one more here, let's use a multi-layer perceptron. Okay, so again, we'll just take the default. Again, I'll come in here and make some modification. So click on Start. And actually, this is the best so far. Rather, yeah, 9.63, not too bad. So let's configure this a little bit. So I'm going to change this to, so let me go ahead and I think this was random forest. So we didn't select that. Let's go Meta functions, multi-layer perceptron. So let's run that. And we can see actually this one outperforms everything, 9.859. And I plug this one here. So 9.859. Can see this 97%, right, of the variance in the housing prices in the data can be predicted by our model. So this actually is one of our best models, right? In fact, we can configure this a little bit. So let's say if we want to configure this a little bit. So hidden layers here, we already saw the idea behind perceptron. Let me change this to 5 maybe. And click on OK, right? And click on Start. Now this actually even goes much higher. So if we do that, do this and calculate the R squared. R squared for this now is 98. It's actually gone up. So this is actually proof that if you configure some of your parameters, there's a high chance that you can improve the performance, right? And again, of course, there are a lot of data preparation steps, you know, like just making sure that you do standardization, normalization. We've already looked at this. You can actually go to filters and try different, you know, you can do discretization if you have nominal and supervised here. You can, you know, do different things here like standardize, normalize, and especially if your data actually has different, you know, magnitudes, okay, for your features. So again, what I did was to, now that we have this, probably in a small video, I'll compare again this model using the test option. All right, so in summary here, we've already looked at some of the popular regression algorithms that we use in Worker. Again, we've used linear regression, simple linear regression, support vector for regression, KNN for regression, bagging and ensemble technique, random forest, and multi-layer perceptron. And last week, sort of tried to improve our performance by fine-tuning the parameters. We call this hyperparameter tuning for our multi-layers perceptron, which just falls under the class of neural network. Okay, as you can see, Worker just provides a very fast and efficient way to implement some of these algorithms for both classification and regression. Maybe in another video, we'll look at also how to perform clustering. All right, that's it for this now.